All right, strap in, everyone. Let's dive deep into some seriously cool tech advanced energy materials.
Yeah, stuff that could really shake things up when it comes to, well, powering our lives.
Think sci-fi, but real. Solar panels on overdrive, batteries that won't go boom, even grabbing carbon dioxide straight out of the air.
It's an exciting time, no doubt. We're talking a potential energy revolution, and these materials are leading the charge.
I see what you did there. So you're up to speed on what we're digging into. Perovskite solar cells,
Mhm.
thermoelectrics, nanopore CO2 capture, solid-state batteries, and those photovoltaic polymers.
Yep, the whole lineup. Each one with the potential to turn the energy sector on its head.
Let's start with those perovskite solar cells then. I keep hearing they're going to blow traditional silicon solar panels out of the water. Is that just hype?
There's definitely hype, but it's for good reason.
Yeah.
Perovskites have this unique crystal structure, makes them crazy efficient at turning sunlight into electricity. We're talking surpassing traditional silicon in some cases. And get this, they can be made much cheaper.
Cheaper and more efficient? Hold on, how are they cheaper to produce? Silicon's been king for ages.
It's all about the manufacturing. Silicon solar cells need all these energy-intensive, high-temperature methods. Perovskites, think more like printing. Simple solution-based stuff.
Printing solar panels. That sounds almost too easy. What's the catch?
There's always a catch, right?
Hmm.
Biggest hurdle with perovskites is stability. They're kind of sensitive. Moisture, oxygen, those can make them degrade, lose efficiency over time.
Like leaving a cookie out in the rain? Not great. But are scientists working on, like, waterproofing those solar cookies?
Exactly. Encapsulation, tweaking the chemistry to make them tougher, that kind of thing. Some are even thinking about putting them in more sheltered places, like inside windows or woven into clothes.
Okay, now that's cool. Solar power jackets, I'd rock that. But let's shift gears to thermoelectric materials. Always sounded super sci-fi to me. Turning heat into electricity? Can we really do that on a practical level?
We can. And
Yeah.
it's a big deal, especially now with sustainability being so crucial. Imagine capturing the waste heat from your car engine or industrial processes, and bam, usable electricity.
Wait, so we could power our cars with the heat they make? That's wild. How does that even work?
It's all about the sea duct effect. Basically, temperature difference across a thermoelectric material creates a voltage. Bigger the difference, the more voltage you get.
Hot side, cold side, boom, electricity. I know that's super simplified, but I'm getting the picture. Aren't these materials still pretty inefficient, though?
That's the challenge, yeah. Scientists are always on the hunt for better materials, ways to improve what we've got. They use a metric called the figure of merit to measure how well a material converts heat to electricity.
So higher figure of merit equals more free electricity from wasted heat.
Exactly. And there are some promising materials out there, like bismuth telluride, lead telluride. They're being used in small-scale stuff now, but we're not powering our homes with waste heat just yet.
I'll keep my fingers crossed for that future. Now, onto something that feels especially important these days, nanoporous CO2 capture. This sounds like a real weapon in the fight against climate change.
It is. We all know carbon dioxide is a big problem, and nanoporous materials can actually trap it right out of the air. Think of it like a super picky sponge, tiny holes just the right size to grab CO2 and hold on tight.
Okay, so we snag the CO2. Then what? Just piles of CO2-filled sponges everywhere.
Well, there are a few options. Some folks are looking into ways to use that captured CO2, like making fuel or other useful stuff. Others are all about storing it underground safely.
So recycle it into something useful or tuck it away where it can't cause trouble. That's clever.
Hmm.
Okay, on to something a bit closer to home batteries. Solid-state batteries? I keep hearing about those. They sound like the ultimate battery, right? Safer, more powerful, longer lasting. Am I getting carried away?
Not at all. You're right on the money. Solid-state batteries could really change the game for, well, everything. Phones, electric cars, you name it.
So what's the big difference between them and those lithium-ion batteries we're all using now?
The key is the electrolyte.
Hmm.
Your phone, your laptop, they all use batteries with a liquid electrolyte. And, those can be a bit flammable.
Yeah, not exactly the kind of heat I want in my pocket.
Right. So solid-state batteries swap that flammable liquid out for a solid electrolyte. Much safer. Plus, they can hold way more energy in the same space.
So longer battery life, smaller devices, and no more fiery surprises. Sounds like a win-win-win. But there's got to be a downside, right? If it was that easy, we'd all have them by now.
Of course. One of the big challenges is finding the right material for that solid electrolyte. It needs to be super conductive so the lithium ions can move quickly, but it also needs to play nice with all the other parts of the battery.
So it's like a Goldilocks situation, finding the material that's just right.
Exactly. But researchers are making progress. Some companies are even starting to, dip their toes into production. So hopefully it won't be too long before we see solid-state batteries everywhere.
Can't wait for my phone to last a whole week on one charge. Okay, last up, we've got photovoltaic polymers. What are those all about? What makes them different from your typical solar panel?
Think of them like flexible solar panels, almost like a thin sheet of plastic that can turn sunlight into electricity. They're made from organic materials, which gives them some unique perks.
So not those big clunky panels you see on rooftops. What kind of perks are we talking about?
Well, for one, they open up a whole new world of possibilities for where we can put solar panels. Think clothes, tents, curb surfaces, even windows.
Solar-powered windows. Hold on. So our homes could be generating energy from, like, every direction.
Exactly. And photovoltaic polymers could be cheaper to make than traditional silicon solar cells, too. They can be printed or coated onto surfaces, which is a much simpler process.
Okay, so they're more versatile, potentially cheaper, and they open up all these crazy possibilities for integrating solar energy into our lives. What's the catch this time?
The main challenge right now is efficiency. They're not quite as good at converting sunlight to electricity as those silicon solar cells.
So room for improvement then. But it sounds like the scientists are on it.
Oh yeah, they're working on new materials, new designs, constantly pushing the limits. The fact that they're made from organic materials means there's a lot of potential for, playing around and finding new ways to make them better.
This is all so mind-blowing. So we've got super efficient and cheap perovskite solar cells, thermoelectric materials that can turn waste heat into power, nanoporous materials grabbing CO2 out of the air, solid-state batteries that are safer and last longer, and photovoltaic polymers that could bring solar energy to pretty much any surface. It's safe to say the future of energy is looking pretty bright, right?
I'd say that's a pretty solid assessment. The research is moving fast, and I'm really optimistic about what these materials could mean for a cleaner, more sustainable energy future.
Feeling pretty optimistic myself. But let's get real for a second. Every new technology has its challenges, right? What are some things we need to be aware of as these advanced energy materials start popping up everywhere?
Good point. These are still new technologies. There are definitely hurdles to overcome. Scaling up production to meet global demand, for example, that's a big one. And we need to make sure these materials can be produced and eventually disposed of in a way that doesn't hurt the environment.
So sustainability has to be a top priority as these technologies develop.
Absolutely. We need to think about the environmental impact of the materials themselves, the energy it takes to make them and recycle them. And we need to consider the social and economic side of things too, making sure these technologies benefit everyone, not just a select few.
So it's bigger than just the science itself. It's about building a fairer, more sustainable world with these materials.
Exactly. And that takes everyone working together. Scientists, engineers, policymakers, businesses, even just everyday people, we all need to be part of the conversation.
It's a good reminder that innovation isn't just about cool gadgets. It's about using those gadgets to make the world a better place.
Couldn't agree more. It's about using science and technology to tackle the big challenges facing humanity, and I think these advanced energy materials are a crucial part of that.
It's pretty amazing to think about all the possibilities.
Mm.
Okay, before we wrap up, I want to switch gears for a second and get a little more personal. You've dedicated your career to this field. What is it about advanced energy materials that really gets you excited?
I'd say don't just sit back and wait. Jump in. The shift to a sustainable energy future, that's a huge, huge task, and it needs every single one of us to pitch in.
I like that. So it's not about waiting for the next big invention to come along. It's about actively creating the future we want.
Exactly. Learn about the issues, support the people working on solutions, push for policies that help clean energy, make good choices in your own life. Every little thing adds up. It all makes a difference.
It really shows that we all have a part to play in shaping the future. This has been an amazing talk, seriously. Thanks so much for sharing your knowledge and your passion with us.
The pleasure was all mine. It's always great to talk about, how science and technology can make the world a better place.
Well, I learned a ton, and I hope everyone listening did too. Who knows, maybe this will spark some new ideas out there, some innovations that can help us move even faster toward a truly sustainable energy future.
Fingers crossed.
To a future powered by clean energy and driven by the bright minds of, well, all of us. That's it for our deep dive into advanced energy materials. Thanks for joining us.